Pre-AP Algebra 4 Final Exam Review Part 2. So we're now on the second page. Starting with number 11, we're talking about evaluating logarithmic expressions. So log base 2 of 32. So what this means is 2 to what power is equal to 32. We're looking for what is that power. Okay. So 2 to what power equals 32? Well, let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we have to do 2 to the 5th equals 32. So therefore, log base 2 of 32 is equal to 5. Okay. Log base 4 of 1 over 64. Well, anytime we see a 1 over something, we know that we're going to have to take a reciprocal. So that means we know that we're going to wind up with 4 to the negative something power is equal to 1 over 64. Okay, well, 4 times 4 is 16, times 4 is 64, so 4 to the third power is equal to 64, therefore 4 to the negative third power is equal to 1 over 64. So log base 4 of 1 over 64 is therefore equal to negative 3, because that's the exponent that I would have to put on 4 in order to make that statement work, in order to get 1 over 64. Now expanding logarithms. So log base 7 of a over b to the 4th. So the first thing that we have to do is look and see that we have the quotient property. Now quotient property means that I'm going to split this up into the difference of the numerator and the denominator. So the log base 7 of the numerator, a, minus log base 7 of the denominator, b to the 4th. Then I have the power property, which means that I take the exponent, and then that comes over here and becomes the coefficient on the front of that logarithm. So log base 7 of a minus 4 times log base 7 of b. Okay. And then number 14, now we've got log base 9 of x times y to the 6th. So now I've got a product property. So a product property is the inverse of the quotient property, so we're going to do a sum instead of a difference. So log base 9 of x plus log base 9 of y to the 6th. Again, we have a power property, so I'm going to take that exponent of 6 and it's going to become the coefficient on that logarithm. So log base 9 of x plus 6 log base 9 of y. For numbers 15 and 16, now we're going to condense, which is obviously the opposite of expanding. So we have expanding and condensing. So we're going to work our way in reverse. So we have a power property, so I'm going to take that 4, that's a coefficient, and it's going to become the exponent. So the natural log of u to the 4th minus the natural log of v. And since we see that minus sign there, we know that we're going to have the quotient property, so this becomes the natural log of u to the 4th over v. Okay. Likewise, over here on number 16, start by looking for the power property, so this 4 becomes the exponent on b, so this becomes log base 9 of a plus log base 9 of b to the fourth, which then can be condensed into product property because of the plus sign. So that would be log base 9 of a b to the fourth. Okay, numbers 17 through 20, classifying conics based on their equation. So since these equations are already written in the forms relative to their conic sections, they're very easy to identify. So whenever we see a minus sign in between two squared terms set equal to 1, we should be able to recognize right away that that's going to be a hyperbola. And that's all that this is asking for, but we can actually tell some characteristics. Because the y term comes first, the y term is the positive term, that means that this hyperbola is actually going to open up and down. Effective if you want to recognize what the graph is going to look like. Okay, so this would be a hyperbola that has a vertical axis. So we've got the branches open up and down. Number 18, we have x squared plus y squared equals 9. Now, especially when you see no denominator on either the x squared term or the y squared term, no coefficients, okay, just x squared plus y squared equals some number, some value over here, some constant value, we know that this is set up as a circle. Okay, with the very basic circle, center at the origin, x squared plus y squared equals r squared. So we can even tell that this is a circle with a radius of 3 and its center is at 0, 0. It has not been shifted at all. Number 19, the key characteristic here is we notice that one of our terms, in this case our x term, is linear. It doesn't have any exponents on it. And our y term is squared. Well, when one of your terms is linear and the other term is squared, then that means that you're going to have a parabola. Okay, and in this particular case, because it's the x term that's linear, x is a function of y, therefore it's either going to open left or right. And because there's a positive coefficient on y squared, we know that this is going to be a parabola that opens to the right. For number 20, notice that it looks very similar to the hyperbola. We have an x squared term and a y squared term, both of which have a denominator and both of which are set equal to 1. So this time we have the sum of those two terms, which means that we are going to have a ellipse. So we have an example of each of the 4 conic sections: hyperbola, circle, parabola, and ellipse. The other thing that we can tell about this ellipse is that because the y squared term has the larger number underneath it, that means that my ellipse is going to be stretched in the y direction. Okay. We can also tell it has not been shifted. There is no h or k associated with the x and the y. Therefore, the center is at 0, 0. And finally, for number 21, it says use the information provided to write the standard form of the equation of the circle. Now, the standard form of an equation of a circle is x minus h squared plus y minus k squared equals r squared, with the center is at h comma k. Well, my center is at 7 comma -4, so all I'm going to do is plug those in. So I get x minus 7 squared plus y minus negative 4 squared equals 8 squared. And then I just simplify. X minus 7 squared plus y plus 4 squared equals 64. Okay, and that does it for part 2.